On the ACT, there are typically only 1 to 2 questions on the topic of solid geometry. Of course, in solid geometry, there are a lot of different types of questions to choose from. In this video, we're going to review solid geometry, in particular volume, surface area, and diagonals. One commonly tested theme in solid geometry questions is that you need to find hidden right triangles. So for example, if you have a cube or a rectangular prism, a lot of the times they ask you to find the length of a diagonal. To find the length of a diagonal, you can either memorize a formula for diagonal length, or you can draw in a right triangle. As you can see in my diagrams for a cube and a rectangular prism, if you draw in a right triangle, it's simply a matter of using the Pythagorean theorem a couple of times to figure out the length of the diagonal. The same can be said for a right square pyramid. If you get a question asking you for the surface area of a right square pyramid, for example, it's important to be able to figure out what is known as the slant height, or L, as shown in the figure on the bottom right. To do so, you need the height and you need the length of one of the sides, divided by 2 of course. Once you apply the Pythagorean theorem, you can get the slant height of the right square pyramid. So again, you can memorize a formula, or if you can recognize hidden right triangles, that will go a lot further for you. Now let's review some formulas for volume and surface area of different solids that you may encounter on the ACT. As a reminder, volume is the amount of space that an object takes up, and surface area is the area of all of the exposed surfaces of the object. We'll start with a cube of edge length s. The volume of the cube is s cubed. The surface area of that cube, since it has 6 faces, is going to be 6 times s squared, where s squared is the area of one of the faces. A right rectangular prism will have a length, a width, and a height, or edge lengths of L, W, and H. To get the volume, we simply take length times width times height. For surface area, we know that we have 2 faces with an area of length times width, 2 with an area of height times width, and 2 with an area of height times length. So if we add all those together, we get the surface area. So we get 2LW plus 2HW plus 2HL. For a right circular cylinder, we will need the height and the radius. Given those, we can calculate the volume, which is going to be pi r squared times the height. For surface area, we are adding up the area of the top and the bottom, as well as the lateral side that goes around the cylinder. For the top, we have the area is pi r squared. The bottom is the same thing, so that gives us the term 2 pi r squared. For the lateral face, we simply take the circumference, which is 2 pi r, and multiply that by the height. So in total, we get the surface area is 2 pi r squared plus 2 pi r h. It is certainly possible for you to encounter a right prism that isn't a cube or a rectangular prism, or, while technically not a prism, a right circular cylinder. So in general, if we have a right prism, to find the volume, you're going to take the area of the base times the height. For surface area, you're going to take 2 times the area of the base plus the perimeter of the base times the height. For a sphere, it's important to memorize the formula for volume and surface area, as they may not always be given. So for the volume, you simply take 4/3 times pi times r cubed. For surface area, you just take 4 pi times r squared. For a right circular cone, the volume is going to be 1/3 times pi r squared times the height of the cone. Surface area is a little trickier to figure out because you first need to figure out the slant height of the right circular cone. To find the slant height, again, you apply the Pythagorean theorem. You should know the radius of the base and the height, and then if you apply the Pythagorean theorem, you can get the slant height. So then you can calculate the surface area, which should be given by the area of the base of the cone plus the area of the rest of the cone. So in total, your surface area will be pi r squared plus pi r L. Finally, we have a right square pyramid with an edge length on the base of a height, and a slant height. Volume is given by the formula 1/3 a squared h. Surface area, again, is a little more complicated, but if you think about it this way, you need to add up the area of the base plus the areas of the 4 triangles that make up the rest of the pyramid. So the formula looks like a squared, which is the area of the base, plus 4, which is the number of triangular faces, times the area of each of those triangles, which is 1/2 a times L. That may look familiar to you because the area of a triangle is 1/2 base times height. So for surface area in total, you have a squared plus 4 times parentheses 1/2 AL close parentheses. Of course, to figure out L, the slant height, you will want to apply the Pythagorean theorem,